Hi everyone, my name is Leah and today I will be presenting a professional development module on using the Frayer Model in mathematics instruction. The Frayer Model is a graphic organizer used to build students' understanding of vocabulary. It focuses on 4 key components: definition, characteristics, examples, and non-examples, and this structure helps students break down mathematical concepts in a clear and organized way. The Frayer Model promotes conceptual understanding by helping students think more deeply about math vocabulary. It uses multiple representations, such as words, examples, and visuals, which supports how students learn best. It also supports all learners and moves students beyond simply memorizing definitions to actually understanding concepts. There are several steps teachers can follow to implement the Frayer Model effectively. First, introduce the term. Next, model how to complete the organizer. Then guide students through practice. Allow them to discuss and justify their answers. And finally, have them apply the concept in a new context. Here is what a blank Frayer model looks like. It is divided into 4 sections, as you can see, including the definition, characteristics, examples, and non-examples. And this structure is really here to help students organize their thinking. For this example, the term we are focusing on is fractions. This is a key concept in elementary mathematics, and as you can see, we placed the key concept in the middle bubble of the model. First, we will define the term. A fraction is a number that represents part of a whole. This gives students a clear starting point for understanding the concept. Next, we'll identify important characteristics of fractions. For examples, fractions have a numerator, a denominator, they show equal parts, and they represent parts of a whole. This helps students understand what makes a fraction a fraction. Now we provide examples such as 1/2, 3/4, and 2/3, as well as a visual representation. Examples help students see what the concept looks like in practice. Finally, non-examples are just as important because they help students understand what the concept is not. For example, whole numbers like 3, 10, and 25 are not fractions. This helps prevent misunderstandings. To use the Frayer model, students can then work in pairs or small groups to complete their own models. They can explain their thinking and discuss their ideas with others. Teachers can circulate and ask questions such as, why is this an example? Or how do you know this is not a fraction? These questions help deepen understanding. This strategy is effective for a wide range of learners. For example, visual supports can help English language learners, and sentence starters can support students who need additional guidance. Advanced students can create their own Frayer models to extend their thinking. The Frayer model can also be enhanced using technology. Students can create digital versions using tools like Google Slides, Jamboard, or interactive whiteboards, which allows for collaboration and makes student thinking visible. This strategy aligns with important math standards. For example, it supports CCSS 3.NF, which focuses on developing understanding of fractions. It also connects to mathematical practices such as constructing arguments and looking for structure. In conclusion, the Frayer model is a powerful strategy that helps students build deep understanding of mathematical concepts. It supports critical thinking, vocabulary development, and engagement. Thank you all for watching, and I hope you use the Frayer model in your own teaching.